Okay, so where I left off in the last video, we were completing this graphic organizer using paragraphs 2 and 3 from Understanding Electricity from that text. Right. I'm sorry, Electricity and Batteries. So we went over paragraph 2 and how that was talking about how Volta created the first battery. And then next, paragraph 3, we were going to reread to figure out how Volta's invention helped with the next event. In the following years, scientists made more discoveries about electricity. One of the most startling of these came in 1820. In that year, the scientist Hans Ørsted observed that a compass needle would move when he brought it near a wire hooked to a battery. Ørsted, knowing that compass needles responded to magnets, realized that electric currents produce magnetic fields. That's important. So we found his discovery there. Okay. Ørsted recognition that electricity and magnetism are related was one of the most important discoveries of the 19th century science. Okay. So when we go back to our graphic organizer, remember event 1 was Volta put small pieces of cardboard between discs of copper and zinc and stacked several of them together. Okay. So remember he was experimenting with electricity there, and then the electricity flowed through a wire attached to the top and bottom of the stack, making a battery. Right? Those two first events occurred in the second paragraph when we were talking about Volta. Because Volta did this and created a battery, that leads to the next event in paragraph 3. Ørsted discovered that a compass needle moves if it is near a wire connected to a battery. Okay, so that's how these events are connected by using paragraphs 2 and 3. Let's read this little note. Paragraphs 2 and 3 don't just describe two discoveries. They tell you how the second one depended on the first, right? Because if Volta never discovered how to make a battery, Ørsted was not able to do this, okay, with the compass and talking about magnetism. Okay. Number 2, we just talked about our graphic organizer and how those two ideas are related. We had to have Volta's battery in order for Ørsted to make his discovery. Number 3, we need to write a short response. Explain how Volta's discovery led to Ørsted's discovery. Use details from the text to support your answer. Use the space provided on page 58 to provide your answer. Hint: don't just describe what Volta and Ørsted discovered. Explain how Ørsted's discovery was dependent on Volta's. Right? So we're going to basically take our graphic organizer and we're going to write a short response. Okay, and that they said was on page 58. So I'm going to go there quickly. Okay. Use the space below to write your answer to the question on top of page 55. Here's the question again, so we don't have to flip back and forth. We read the hint earlier to describe how they depended on each other, right? Here in blue, I have an example. Okay, the reason why I'm showing you this is because this is what I'm expecting you to be typing out in the assignments on the last question. Remember I told you it's like an essay type question where you need to have a short response. You're using text evidence, right? You're quoting from the text to support your answer in your short response. Okay, so this should be at least a couple of sentences. Here it's probably about 3 or 4. Okay, so I'm going to read to you the response that we're looking for. Remember, we're going to explain how Volta's discovery led to Ørsted's discovery. Use details from the text to support your answer. Okay. When Alessandro Volta invented the battery in 1799, he produced an object that could make electricity flow through wire. Okay, so this is all from paragraph 2, right? We know that he invented the battery. We talked about in our answer what the battery did, right? It made electricity flow through wire. Then in paragraph 3, years later in 1820, Hans Ørsted saw that the needle of a magnetic compass would move when he brought near a wire hooked up to a battery. This observation suggests that electricity flowing through the wire could produce a magnetic force. Okay, so we're describing how we said what Ørsted's discovery was, right? He saw that the needle moved when he brought the battery up to it, and this suggested that electricity flowing through the wire could produce a magnetic force. This observation led Ørsted to discover that the forces of electricity and magnetism are closely related. Without Volta's invention of the battery in 1799, Ørsted might not have made his discovery about electricity and magnetism. Okay. So, what you're going to do next, let me go back up. Okay. I want you to read the second source. So this source is not a scientific text, it's a technical text. Remember in the first video, I told you that a scientific text teaches you facts and ideas about the natural world, but technical text is like instructions on something. It teaches you how something works, how it is used, how to make something, how to do something. Okay, so if you're looking at this, I can already infer, because it's a technical text and it's talking about battery power, I'm thinking it's going to teach me how a battery works. That's just a hypothesis. I have not read this yet. Okay, so I'm going to read this aloud with you. Okay, I'm going to talk, so we're going to read it one time. We're going to talk about the closed reader habits. We're going to go through them. And then what I want you to do, in preparation for Wednesday's Zoom meeting, you're going to answer the following questions. Let me show you those. Oops, I'm sorry. Okay, so battery power. Yours will look like this. It won't have my notes on it, so that's why it's important to watch the video. Okay, you're going to answer these questions on page 57 and 59. Okay, and we'll talk about those on our Zoom meeting on Wednesday. But before we do that, we're going to go through the text together, and then I want you again to answer the questions on your own for Wednesday's Zoom meeting. That'll be like a guided practice. And then after our Zoom meeting, you'll have Wednesday, Thursday, and Friday to complete the assignment for this week, right? Which is going to be the last text in this packet, okay? So let's start here. This experiment tells how to make a battery similar to the one Alessandro Volta made. The chemical reaction of salt and vinegar in the presence of copper and zinc makes electricity flow through wire. Okay, so then you see it's a technical text and it's going to be telling us how to make a battery, right? Remember, technical texts tell us how to. Battery Power by Gary Gibson and Science for Fun Experiments. Paragraph 1. Find 12 copper coins and zinc washers of similar size. They will need to be stacked. Cut out 12 same-size circles of blotting paper. Paragraph 2. Pour vinegar into a glass with a tablespoon of salt. Soak each piece of blotting paper in the mixture. Stack a coin then a washer on a piece of blotting paper. Finish with a washer. Paragraph 3. Take 6.5 feet of thin plastic coated copper wire. Coil it tightly around the iron nail as many times as you can. Oh, I see that here. Okay. Paragraph 4. Attach one end of the copper wire to the bottom coin and the other to the top washer. Paragraph 5. Test your battery by bringing the nail close to a small compass. The nail should make the compass needle swing. Interesting. That sounds like that's Ørsted's discovery. Paragraph 6. Why it works. The salt and vinegar start a chemical reaction. Negatively charged particles flow through coins to the washers around the wire coil and back to the battery. The electric current creates a magnetic field that affects a compass needle. Here's a footnote. The negatively charged particles are bits of matter called electrons. Oh, so these particles that they're talking about are electrons. Negatively charged electrons flowing through the coins and the washers around the coil and back to the battery. All right, so we're creating like this whole system here. Okay, let's find out why we have all this highlighted and circled here. That will be the closed reader habit. Remember, yours will not look like this, so I'm giving you a little sneak preview here of how you should be doing this, okay? So on your final text on this packet, you won't have this information, right? You'll have the closed reader habit, and that's something that I want you to be doing maybe on a separate piece of paper or making notes of these important things from the closed reader habits. Closed reader habits. What steps? Okay, so we're going to focus again on the steps. I remember in the previous text we were looking at the steps that Volta made. Okay, what steps and materials are needed to make the battery? Reread the text, circle words and phrases that tell you this. Okay, so we have the first step, find 12 copper coins and zinc washers. Okay, so we're basically knowing our materials here. 12 copper coins and zinc washers. 12 same size circles of blotting paper. I would have circled blotting paper because that doesn't stand out to me with what they're doing here. Okay, now we have the steps. Pour vinegar into a glass. Then we have a material, tablespoon of salt. Soak each piece of blotting paper. Stack a coin, then a washer. Right. Coil it tightly around an iron nail. Attach one end of the copper wire to the bottom coil and to the top washer, bringing the nail close to a small compass. All right. And that's to test out your battery to make sure your battery is working and those particles are correctly flowing through all around the battery. Okay, so again, you are going to complete these questions on your own on page 57 and the short answer on 59. Okay, and we'll talk about this on Wednesday's Zoom meeting. I'll see you then. Okay, for our assignment for this week, you are going to be on your own. I'm going to just give you a preview and we'll talk about this on our Zoom meeting also. You're going to be reading the technical text, Hydroelectric Power by the United States Geological Survey. Okay, so you'll read the text. Okay, this is going to be on the assignments tab after Wednesday. Okay, and I recommend you use the closed reader habits that we used in the previous text in the videos. I will talk to you guys again on Wednesday in our Zoom meeting. See you later.